Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. And in this module we are trying to understand how the operating system manages the CPU by providing this abstraction of a process, right? So within the second module we are currently on the second topic, that is process address space. And here through a series of videos we are trying to understand how does the memory appear to each process, right? So we know that every process has an associated process address space, and it helps to organize the code and data for that process in the memory, right? The process address space has different sections. We have already talked about the code and stack section. And so basically, before we start talking about the next sections, that is data section and heap section, there is a very crucial concept or important concept that we should be aware of. That is, we should know what is static and what is dynamic memory allocation, and what are the differences between them, because they will be required to understand that what does the data section contain, or why do we need the heap section, right? So that is why in this video we are going to study what is static and dynamic memory allocation, and what is the difference between them. So without further ado, let's get started. So let us start the discussion by recalling what all we have learned about the different sections in the process address space. So as you can see, this is the process, and here we have the address space. So these are the different sections: code, data, heap, and stack. And we have already studied about the code section and the stack section. So we know that the code section is used for storing the instructions of the program, right? So when we compile the source code, we get a program, and that program has two major parts. One is the instructions and the other is data. The instructions of the program go into the code section. And if you see, apart from the code section, so basically it is only the code section where the instructions are there, right? Apart from the code section, all the other major sections that are part of the address space, they store some type of data, right? The stack section is used to store the local variables, so the arguments and the local variables that are part of the function body, right? The stack is a place which stores these kind of data, basically the data that is local to the functions or the arguments, right? We know that the stack is used for the execution of the functions, right? It has this dedicated purpose for executing the function calls. But if you see from the perspective of a data storage, it is also a place where the local variables and the arguments, basically all the data that is associated with the function, that data goes into the stack section. So the point that I'm trying to tell you is that only the code section contains instructions. The rest of the sections contain some type of data. Now, we will study this in the next few videos, that the heap section is a pool of memory that is reserved for dynamic memory allocations. So what is static and what is dynamic memory allocations, which we will study in this video, right? But I'm laying out the context and the motivation of why we need to understand the static and the dynamic memory allocation. So the heap section is basically, as we will talk about this in the next videos also, it's a memory section in the address space which is reserved only for the dynamic memory allocation. It's a pool of memory, right? And then the data section, which we will talk about in the next video, it collects several objects like global variables, static variables, constants, all of these pieces of like data objects that it stores. All of this, the common nature of these objects are that they are statically allocated memory, right? So the data section stores a whole bunch of things, and the common thing among all of them is that all of them are statically allocated. So that is why we need to have a good understanding of what is static and what is dynamic memory allocation, and what is the difference between them, so that when we start talking about the data and the heap section, then we can understand them properly. So now let's start and discuss what is static versus dynamic memory allocation. So as you can see, what is static memory allocation? The static memory allocation is basically that memory for which the size remains fixed during the program execution, right? So a memory which has been allocated statically, the basic property of that kind of memory is that its size will always remain fixed throughout the execution of the program, right from the starting till the program ends. Its size will not change. So let us see some examples. So let's say there is a character array that is text, and it is of 6 bytes, right? And it contains this hello string. So as you can see, its size is 6 bytes, and since it's statically allocated, its size will not change during the entire duration of the program. Other examples are primitive data types like integer, float, bool. So all of these are statically allocated. The size of these data structures is known before runtime, right? When we compile the piece of code, when we compile the code to generate the program, at that time only we know that the size of integer, we know how much size it will occupy. So these primitive data structures, as I said, like integer, double values, float values, all of this, the size is dependent on the runtime, the language, and the machine, right? So integer variables can be 2 bytes or 4 bytes. So whatever be the size of this will not change during the execution of the program. So this is static memory allocation, right? And let's talk about the dynamic memory allocation. So basically the property is reverse. The property of dynamic memory allocation is that these data structures or these variables, the size of these variables can change. It can grow, it can shrink during the execution of the program, right? Some examples of dynamically allocated data structures, as you can see, are linked lists and trees, right? So in a linked list, right, this linked list, the nodes that are there, they are in a chain, and the number of nodes can vary, right? It can vary on the basis of input or whatever. The linked list can grow. We can delete the nodes, or the linked list can grow. We can add new nodes, or we can shrink the linked list by deleting some nodes. Basically, the size of the linked list can change during the execution of the program, right? Similarly, another example of a dynamically allocated data structure is the tree. In tree, the we can add different nodes. The height can increase or decrease, and basically it's the same as the linked list. We can the size of the tree can grow or shrink during the execution of the program. So this is the basic difference between static and dynamic memory allocation. So the question that you need to ask is that, will the size of this memory change during the execution? If this answer is no, then you can go for static memory allocation. And if the answer is yes, the size can change, it can grow or it can shrink, then you should go for dynamic memory allocation. So now that we have understood what is static and dynamic memory allocations, we will talk about some differences between them, right? So the first difference we have already talked about, which is the definition. So the definition, as we know, the size for static memory allocations remain fixed, whereas for the dynamic memory allocations, the size can vary. They can grow or shrink during the program execution. So now let's talk about some other points, right? So the first thing that I want to talk about is, when does static memory allocation and dynamic memory allocation happen? So static memory allocations happen during compilation. So when you're compiling your source code, right, and generating the program, during that process, since the size of static memory allocations will remain fixed, right, the size, since it is remain fixed, that can be reserved during the compile time only, right? We do not need to wait for the program to start running. We do not need to wait till the runtime. So the size of these memory allocations, these memories can be decided at the compile time, right? And for the dynamic memory allocations, basically this will happen when the program starts running, when we have a process, right? When the instructions are executing, when the program is running, that is called runtime. And during the runtime, the dynamic memory allocation will happen, right? So one point that I want to talk about in the context of static memory allocation is that you can ask this question that when we say static memory is allocated at compile time, right, what do you mean when you say allocated? The program has not yet started running, right? There is nothing in the DRAM, there is nothing in the physical memory. So what do you say when you what do I mean when I say static memory is allocated during compile time? So here we are basically saying that we are deciding upon the size, right? We know we are kind of reserving the space. We are not actually allocating that memory in the DRAM. That will obviously happen when the program starts running, but we are deciding upon how much size will be required for this variable. That part at least can be decided at compile time, right? Basically, that address space layout is created, right? Let us in the data section, which variable will be at which address. Since we know the size of all this memories, right? We know the size, so we can decide upon, okay, at this address there will be this much size for this variable, then at this address this static variable will take this much size. So when we say static memory allocation happens during compile time, here we are basically saying that the size of these variables or these data structures is kind of decided during compile time. Obviously when the program starts running, then it will the actual memory will be allocated, right? So this was about the difference of when the static versus dynamic memory allocation happens, about the timing. The next difference, the next two differences actually talks about how actually the allocation takes place. Now, when the program starts running, how do the static memory allocations and the dynamic memory allocations look like? So when you talk about allocation, so at compile time, the size that these variables or these data structures would require is already decided. So when the program is launched, then this memory is automatically allocated for the program by the operating system. Here, when I say automatically, I mean to say that the programmer does not have to do anything. The size of all the static memory allocations has been decided, it has been reserved. Now when it starts running, when the program starts running, the actual memory in the physical DRAM will be allocated to those variables by the operating system. It happens automatically. You as a programmer do not have to do anything explicitly. And this is where the dynamic memory allocation differs from static. So in case of dynamic memory allocations, the memory must be explicitly allocated using some function calls, right? So the programmer has to write these or call these functions. For example, if they are programming in the C language, then the functions are malloc and calloc. For C++, it is new, right? So here the programmer has to explicitly write the code for making the dynamic memory allocations, right? Whereas in the case of static, it happens automatically, right? Then let's talk about deallocation. The deallocations remains the same. For static memory allocations, basically all that memory will remain throughout the program execution. Once the program is started, once the memory has been allocated statically, they will not change. They will not basically the size of those variables will remain fixed. Also, those memory will not be deallocated. Only when the program terminates, then the memory which has been statically allocated will be freed by the operating system. Again, here the programmer does not have to do anything explicitly. They start the program, the memory is allocated by the operating system, and when the program finishes, the statically allocated memory is automatically freed, right? But as in the case of allocation, similarly, when we talk about the deallocation process, here the programmer has to explicitly deallocate the memory by making function calls. So in C language, the function call is free. In C++, the delete function is there, right? So here the memory has to be managed explicitly by the programmer in the case of dynamic memory allocations, right? For allocation also, they have to make function calls. For deallocations also, they have to explicitly do it. And if they do not do it, then there is the chance of memory leaks. So what is a memory leak? So basically, when you allocate something dynamically, right, it will not be freed on its own. Yes, all of the memory will be freed when the program terminates. That is a different case. But let's say there is a program, it is running and it has a sequence of allocations and deallocations. And you're only allocating, let's say, you're not freeing up the memory. Let's say there are 10 allocations that need to happen. And these are big memory allocations, right? If you do not free the memory once it has been used, then subsequent memory allocations might not succeed because you have not freed the previous memory, right? So that is called memory leak. The memory which has been allocated and it was not freed, right? So that memory is kind of now unusable. It will not be reallocated to some other variable. So that is a memory which got leaked. So here the programmer has to be careful and they have to explicitly deallocate the memory properly so that it is so that memory leaks do not occur, right? Then let's talk about the efficiency. As you can observe that in static memory allocation, the size will remain fixed. So if there is a chance that the entire memory that you allocated is not being used, then memory wastage can occur. For example, let's say you have created a character array to store the name of a person, and you do not know upfront before running the program that how will be the input like. Let's say the user will input some name, and the name can be short name, then the name can be long also. So you just were very generous. You allocated, let's say, 100 characters for the name. but generally the names are only short, right? 10, 20, 30 characters. So the rest of the characters will get wasted. So in the case of static memory allocations, there is a chance that the memory that was allocated, it might not be fully used and it can get wasted. Whereas in the case of dynamic memory allocations, these allocations happen on demand. Whenever you need a new node in the linked list, or let's say for example of the tree, whenever there is a demand for new memory, then only we do such an allocation. And when we are done with the, ideally when we are done with using the memory, then we do the deallocation. So here the scope of memory wastage is less, right? Unless the programmer does some error or they are not careful enough, then memory can get wasted. But otherwise, dynamic memory allocation avoids the memory wastage. Let's talk about reusability. When I say reusability, let's say you have allocated some memory. Can that memory be deallocated and allocated to some other variable? Can this memory be reused? As it happens that in the case of static memory allocation, the memory which has once been allocated to a particular variable, it will be allocated to it for the entire duration. It cannot be reused because statically allocated memory is not deallocated before the program terminates, right? Once it has been allocated, it's done. It cannot be reused during the execution of the program. Whereas in the case of dynamic memory, we can allocate it, we can deallocate, and again allocate the same memory to some other variable or data structure. So in the case of dynamic memory allocation, here the control is with the programmer and the memory can be definitely reused, right? Then let's talk about the simplicity. So static memory allocations are definitely very simple because the programmer does not have to do anything explicitly. All of the allocation and deallocation has been taken care of for you by the operating system. Everything happens automatically. When the program starts, the allocation happens. When the program finishes, the deallocation happens on its own. So in this way, it's very simple. Whereas in the case of dynamic memory allocation, it is somewhat complex because first of all, you have to allocate it explicitly. When you're allocating, you must have be aware of how much allocation do you want to make, right? And you also have to deallocate the memory because if you do not do it, then there is a chance for memory leaks. So here the onus is on the programmer. There are responsibilities on the programmer, and if they do not do it properly, then there is a chance that memory will be wasted. So it's in a way more complex and has more responsibility on the programmer. The final point that I want to talk about is when should you use static memory allocation and when should you go for dynamic memory. So if you go by the definition, the size of the static memory will remain fixed. So if your use case is such that you know that the size that you are going to require, it will be of a fixed size, then you can go for static memory allocation. Let's say you are, you know that the input that is coming, it is, let's say, of a certain length. Let's say it will always be of 10 characters or 20 bytes, whatever is the number in your mind. If you know that this memory allocation is going to be of a fixed size or within a fixed size, let's say you don't know the exact size, but you know it will be at most 50 characters, then you can go for static memory allocation, right? Because here the size will not change. If you need more memory, then it won't work for you, right? So if you have a definite upper limit in your mind and it is not too big, then you should go for static memory allocation. Otherwise, if you're not sure exactly how much memory you would be requiring when the program, before the program runs, right? You should have the knowledge before the program runs that how much memory you would be requiring. If that knowledge, if that clarity is not there, then you should go for dynamic memory allocations. For example, the linked list or the tree. These data structures, or it could be dynamic arrays also. These data structures, the memory that will be required for them depends on how is the input coming and all those things. So we cannot predict before the program starts running that how much memory we will be requiring. So in that case, we should go for dynamic memory allocation. So now that we have understood what is static and what is dynamic memory allocation, we have laid the foundation which we will need for the upcoming videos when we talk about the heap section and the data section, right? So as we will study in the subsequent videos, we said that the heap is a region in the address space which is a pool of memory reserved for dynamic memory allocations, right? All of the dynamic runtime, all of the memory requirements that arise during the runtime are fulfilled from the heap section, right? And similarly, for the data section, it's not that everything which is allocated statically goes into the data section, but all of the data objects that go into the data section, as we'll talk about in the next coming videos, global variables, static variables, the constants, all of those are allocated statically, right? So guys, this was it for this video. In this video, we understood what is static and what is dynamic memory allocations, and we talked about several differences between them. And now we have the requirements, the prerequisites ready, which we need for studying the next video, that is data section and heap section, right? So this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.